Nice. Time to test your knowledge again. We've covered 4 of the most common rules for calculating derivatives: the constant rule, the power rule, the constant product rule, and the sum rule. Let's do a few comprehension exercises now to see how well you understand them. All right, the first question is, differentiate y equals negative 5x cubed. The second one is, differentiate y equals 2x squared plus 2x plus 2. The third is, differentiate y equals 10x to the power of 5 minus 6x cubed minus x minus 1. And then finally, use paper and pencil, that is the derivative rules, to find the slope of y equals x squared plus 2x plus 2, where x equals 2, and separately find the slope where x equals negative 1. Cool, for our first question here, we have a relatively simple one. We have y is equal to negative 5x cubed. Well, to solve this one, we're going to need the power rule. That's clear enough. We've got a power. And then we've got a constant in front, so we're going to use the constant product rule as well. So as a part of the constant product rule, we know that we can just kind of leave the constant alone on its own while we calculate the derivative on x cubed here. And the derivative of that, using the power rule, comes out to 3x squared. Then we can bring negative 5 back into the picture. Negative 5 times 3 gives us negative 15x squared. All right, question 2. We've got y equals 2x squared plus 2x plus 2. We'd like to calculate the derivative. So to do that, we can take advantage of the sum rule to treat each of these 3 terms separately. So let's tackle the first term first. Well, we can use the power rule here, and we're also going to need the constant product rule. So we can treat this 2, this constant, separately, and then calculate the derivative of x squared using the power rule. Well, the derivative of x squared comes out to 2x to the power of 1 using the power rule. And then we still have our constant here. Let's deal with that later. Jumping over to the second term here, again, we'll use the constant product rule to leave the 2 separate for the moment and calculate the derivative of x on its own. Well, the derivative of x on its own is, so implied here is x to the power of 1. And x to the power of 1, we bring the 1 in front, and 1 minus 1 comes out to 0. So anything to the power of 0 comes out to 1, and 1 times 1 is 1. So that's all we're going to be left with there. But before we get to that row, let's talk about our final term. Well, we know from the constant rule that any constant without a variable, when we derive that, it comes out to 0. All right, so now we've got our line here. We can keep moving. We've got a 2x to the power of 1. Well, that's equal to 2x. And as I already just described, kind of jumped the gun there, 1x to the power of 0 is simply equal to 1. And then finally, simplifying things here, bringing the constants back into the picture. 2 times 2x is 4x, and 2 times 1 is 2, leaving us with a final answer of 4x plus 2. In a lot of ways, question 3 is quite similar to question 2. In it, we have a number of terms that we can treat separately thanks to the sum rule. And within each of those terms, we often have a constant. And so thanks to the constant product rule, we can treat those constants separately while performing the derivative calculation on whatever's left in the term, and typically using the power rule, in fact, entirely using the power rule to calculate our derivatives. So x to the power of 5 gives us 5x to the power of 4. We just leave our constant 10 out in front for now. X cubed, when we differentiate that, we end up with 3x squared. And we can just leave our 6 out in front. X, just as we saw in the last question, the derivative of that comes out to 1x to the power of 0. And the derivative of a constant, according to the constant rule, comes out to 0. So now simplifying by bringing the constants back in, 10 times 5 gives us 50, x to the power 4. 6 times 3x squared gives us, negative 6 times 3x squared gives us negative 18x squared. And finally, this term, just as in the last question, comes out to 1 because x to the power of 0, anything to the power of 0 comes out to 1. Multiply that by 1, leaves us, multiply that by negative 1 actually, leaves us with negative 1, and the 0 is nothing. So our final answer is right here. Now for our fourth and final question. Y is equal to x squared plus 2x plus 2. Well, following the same patterns as the last two questions, it should be pretty quick for you then to figure out that the derivative of y with respect to x is 2x plus 2. So power rule here, x squared becomes 2x to the power of 1, which is just 2x. And constant product rule and power rule again here. X, as we saw in the last two questions, comes out to 1, and 2 times 1 is 2. Our constant 2 becomes 0, so we can just forget about that. So we've got our derivative, 2x plus 2. Now we can use that derivative to calculate the slope of this curve at any given point on the curve. So we can plug in at a value where x is equal to 2. We just plug in 2 here, 2 times 2 plus 2. 2 times 2 is 4. 4 plus 2 is 6. And same kind of thing in negative 1. Plug negative 1 in for x in this equation here. 2 times negative 1 is negative 2. Negative 2 plus 2 gives us 0. So what this means is that at the point of our curve here, where x is equal to 2, the slope at that point is equal to 6. And at the point on the curve where x is equal to negative 1, the slope is flat, it's 0. And both of these examples are ones that we covered in code already. So let's go have a look at those plots quickly, just to freshen your memory. So we'd seen these already with hands-on code demos, and we solved them using other approaches. But now that you know these rules, you can calculate them quickly with paper and pencil as well. So here's a plot from our Jupyter Notebook of the curve from the question, the x squared plus 2x plus 2 curve. And here's a situation where we use the delta method to calculate the slope where x is equal to 2, and we found that that came out to 6. And now, with the derivative rules, you could use those rules instead of all the computation that we did in this notebook. And similarly, we also solved where x is equal to negative 1. So that was a question that I gave you earlier in these live lessons. And so at that point, we determined that the slope is equal to 0 using the same kinds of formulae as we did for finding the slope where x is equal to 2. Hopefully that ties together nicely everything that we've covered so far. Coming up next, I have some more advanced differentiation rules for you to learn.